Welcome back to the Security++ Bootcamp Vault. Domain 3 begins now. Episode 10, Objective 3.1, Architecture Models, where your systems live, cloud, on-premises, virtual machines, containers, serverless, and the strange corners like IoT and industrial control. Every home has trade-offs, and the exam tests whether you know what each one costs. Let us go. Objective 3.1 says, compare and contrast security implications of different architecture models. 2 questions run through everything. Who controls the infrastructure, and who is responsible for securing which part? Answer those 2 for cloud, on-premises, virtualization, and the specialty systems, and this objective is yours. Let us walk the homes one by one. Rent or own. Cloud means renting someone else's computers. You scale fast and buy no hardware, but you trust a provider, and your configuration mistakes can be publicly visible. On-premises means your building, your rules, full control and full responsibility for buying, patching, and guarding everything. Hybrid is both at once, sensitive systems at home, scalable work in the cloud, which also means 2 environments to secure, and the exam favorite, the responsibility matrix. The provider secures the buildings and hardware. You still secure your data, your accounts, and your configurations. A leaky bucket is your fault, not the cloud's. Modern wrinkles. Third-party vendors sit inside your stack now, and their breach is your breach. That is the supply chain lesson from Episode 6, Wearing Architecture Clothes. Infrastructure as code means your servers and networks are defined in script files, versioned, repeatable, testable, and 1 typo away from deploying the same mistake everywhere at once. Serverless goes further. No servers for you to patch at all, just your functions running on the provider's platform. The trade. Total dependence on the provider, and any flaw in your code is still yours. Machines inside machines. Virtual machines are whole fake computers, each carrying its own operating system on a shared host. The Nightmare's VM escaped from Episode 7, breaking through to the host. Containers are lighter. They share the host kernel instead of carrying their own. The cost is that 1 kernel flaw touches every container on the box. Microservices split one application into many small parts, talking over APIs. Great flexibility, and every one of those connections is now a thing to authenticate, encrypt, and monitor. Checkpoint 1. Company data leaks from cloud storage that was set to public. The provider's hardware was never breached. Who is responsible? A, the cloud provider, B, the customer, C, the internet carrier, D, no one. Shared systems. Think about the responsibility split. Pause now. The answer is B, the customer. The provider secures the buildings, the hardware, and the platform. The customer owns the data, the identities, and every configuration choice. A bucket set to public is a configuration choice. This split shows up on nearly every exam, so say it once more. The provider secures the cloud. You secure what you put in it. The small stuff. IoT devices, cameras, sensors, smart TVs, are small computers with weak passwords, rare patches, and very long lives. Embedded systems are computers inside other things, often running a real-time operating system, RTOS, built for timing, not security, and often impossible to update. So how do you protect what you cannot patch? You already know. Segmentation. The camera network gets its own room, away from everything that matters. The exam asks this exact question, and segmentation is the answer it wants. The heavy machinery, industrial control systems, and their supervisory flavor, SCADA, run physical processes, valves, turbines, water treatment, assembly lines. They scare people for good reasons. They were built decades ago, they run continuously. Patching them means stopping the plant, and a successful hack can hurt actual humans, not just data. The defense is separation. Air gaps where possible, strict segmentation everywhere else. Keep the machines that move real things far away from the network that reads email. Checkpoint 2. A hospital has hundreds of infusion pumps that can never be patched, but they need network access to report to the nurse's station. What is the best protection? A. Install antivirus on each pump. B. Replace them all immediately. C. Place them on an isolated network segment. D. Disable their network features. What is realistic and what keeps them working? Pause now. The answer is C. Segment them. You cannot install software on the pumps. Replacing hundreds of medical devices is not realistic, and they need the network to do their job, so they get their own segment with strict rules about who can talk to them. Notice this is the same answer for IoT, for legacy servers, and for industrial systems. Unpatchable but necessary means segmentation. Learn it once, score it 4 times. The trap list. Trap 1. The provider secures the cloud, you secure what you put in it. Misconfiguration stories always point at the customer. Trap 2. VMEs carry their own operating system. Containers share the host kernel. Lighter but one kernel flaw hits them all. Trap 3. The unpatchable pattern. IoT, medical devices, industrial systems, legacy servers. Cannot patch plus must stay connected equals isolated segment. Same answer in 4 costumes. Lock it in. Cloud is rented. On-premises is owned. Hybrid means securing both. The provider secures the platform. You secure your data, identities, and configurations. Infrastructure as code makes the network a version text file. Serverless removes your servers, but not your responsibility. VMEs carry their own operating systems. Containers share the kernel. Microservices multiply connections. And the small and heavy stuff, IoT, embedded, industrial, lives long, patches never, and gets its own segment. Objective 3.1 done. Next time, Objective 3.2, Securing Enterprise Infrastructure. Where to place firewalls, what a screen subnet is, the difference between IDS and IPS placement, VPNs, and the modern acronyms SD-WAN and SASE. The Fortress Blueprint episode. See you inside the vault.